Good morning and welcome to Tuesday, April 7th. This is algebra. Yesterday I gave you a problem that was to solve the system of linear inequalities. Well, I gave them to you in slope-intercept, so it shouldn't be too hard to graph them. The first line has a y-intercept of positive 2, so I put a dot right there, and a slope of negative 1/3. That means you're going to go down 1 to the right 3, and put a dot and connect the dots with a line. It's supposed to be a solid line because it does say greater than or equal to. That's how you know if it's solid versus dotted. The second line has a y-intercept of negative 1, and it's got a slope of positive 2, up 2 over 1. It's also got just less than, not or equal to. So I have to make a dotted or a dashed line. The first line has its little guy over here, and the second line has its little guy hiking uphill. The first line said greater than, so I'm going to shade above and around this guy all the way through. The second line said less than, which is under the guy, under his feet, not over him. So it's over here. And what you'll notice is that the area where the two shaded regions overlap is the area of the solutions. Also understand, it doesn't really end there. It's going to keep going up and that way forever and always. It's a very, very large area for all the solutions that make the inequality system correct. Well, let's take a coordinate we think is in that shaded region and test it. I think that the coordinate, let's say 5, 2, 1, 2, 3, 4, 5, 1, 2. It looks like it's inside the shaded area. So I'm going to test the coordinate 5, 2. Of course, there was an infinite supply of coordinates we could test. I just chose that one. All right, if it works, it's got to work for both. So I'm going to do the first equation first. 2 has to be greater than or equal to negative 1/3 times 5 plus 2. All right, negative 1/3 times 5 is negative 5/3 plus 2. Negative 5/3 is negative 1 2/3 plus 2, which means 2 has to be greater than or equal to 1/3, which it is. Okay, so far so good. The other line has to also work, so 2 has to be less than 2 times 5 minus 1. This one's easier. There's no fractions here. What's 10 minus 1? 9. And 2, definitely less than 9. So we can see in our system of linear inequalities that we've got a solution that works. So the shaded region is the answer to the problem. Don't just give me one coordinate as the solution. 5, 2 works, but it's not the solution. It's a solution. The shaded region is the set of all solutions. So as you can see in systems of linear inequalities, we're looking for graphs to solve these problems. All right, now so far you've had all the answers, or all the problems rather, given to you in slope-intercept. But of course, that might not always be the case. So here's what to do when you don't have the question always phrased in the ideal graphable form. There's one and here's the other. Okay, so there's two lines, and I obviously have to put both of them on a graph, so I want them to be graphable. Put them in slope-intercept. Mathematically, that was a positive 4x, so I need to subtract 4x from both sides, giving me 2y greater than or equal to negative 4x plus 10. And then I'm going to divide everything by 2 to get the y by itself. Y is greater than or equal to negative 2x plus 5, and that's graphable. The other line, I'm going to subtract x from both sides, and be careful how you write it down. So I have negative y equals negative x plus 3. I'm sorry, not equals, greater than or equal to. Don't forget, greater than or equal to. Now, I have to divide everything by negative 1. Negative y is negative 1y. I don't want negative 1y, I want y. So I have to divide everything by negative 1. Please remember that when you're dealing with inequalities, multiplying or dividing by a negative number is going to take that symbol and flip it around. So what was once less than is now greater than, or vice versa. So this now it says y is less than or equal to x minus 3. It's a very important thing to remember because it will change our answer, obviously. All right, I'm going to graph this as best I can. 1, 2, 3, 4, 5, 6, 7 up. 1, 2, 3, 4, 5. As many as you can fit in and keep it fairly uniform. My first line has a y-intercept of positive 5. 1, 2, 3, 4, 5. And the slope is negative 2. Again, negative 2 means you're going to go down 2 to the right 1. And you can do it again if you like. It says greater than or equal to, so it's going to have a solid line because it has the equals option. And the second line has a y-intercept of negative 3. And the slope is 1. Remember that when x is by itself, it's got a coefficient of 1, which means up 1 to the right 1, and so on and so forth. It's also going to be a solid line because it says less than or equal to. All right, so I got my two guys on my two lines. Again, you put them where gravity would dictate. Obviously, they can't be hanging from the underside of the line. And now we're going to shade. Now, that first line had a symbol of greater than or equal to. So I'm going to shade above, all around the guy, just not below him. The second line had a symbol of less than or equal to. Now, that's less than. It's under him, under his feet, just not around him, under him. Here we go. And as you can see, it's now crossing in this zone over here. So the place where the two shadings overlap is the solution to our system. Let's check one out. All right, so it looks like, I'm just going to use an easy coordinate. It definitely looks like the coordinate 4, 0, right there. That's definitely in the shaded region. You could choose any coordinate that looks like it's in the shaded region. That one looks easy to me. Which means that I need to check whether it actually works. So is 0 greater than or equal to negative 2 times 4 plus 5? Is 0 greater than or equal to negative 8 plus 5? Is 0 greater than or equal to negative 3? 0 is greater than any negative number, so yes, it certainly is. And in this equation, I have 0 is less than 4 minus 3, less than or equal to. So is 0 less than or equal to 1? Of course, 0 is less than 1, so the solution worked. We verified that our graph looks like it's the correct graph. The value within the shaded overlap does work, and we can feel confident we did it right. Again, it's easiest to graph them when they're in slope-intercept form. So take that time, carefully put them in slope-intercept. Please remember again, when you divide or multiply by a negative number across an inequality, it reverses the symbol. If you don't do that, it's going to lead to some wrong answers. All right. Well, I only really have one more problem I want to show you today, and it has to do with a special system. What are special systems? Those are the systems that have either infinite solutions or no solution. So I'm going to show you this example. I'm going to put it, let's see, one of them will start out in slope-intercept, and the other one is not. So the challenge here, of course, is to graph them so that we can see the solution. And to graph them, I have to put them in slope-intercept. This one already is. That one is not. So I'm going to add x to both sides. Y is less than x plus 1. And the other one already was in the right form. So I'm just going to graph them. So I have 1, 2, 3, 4, 5. Doesn't much matter as long as you have enough to fit the two lines on. All right, so my first line has an intercept of positive 3 and a slope of 1. Again, nothing in front of the x means that the number 1 is the coefficient. Up 1 over 1, a solid line. I'll put my guy on the line. It says greater than or equal to. Well, greater than or equal to is above him, so I'm going to shade above him. And we're good on that line. Now the second line has an intercept of +1 and a slope of, again, 1, so it's up 1 over 1. It's a dotted line because it does not equal. And I put my guy on. This one says less than, so it shades under him, under his feet. And what do you notice? Well, those lines are parallel. You already probably knew that because you saw that they had the same slope. Because I shaded in opposite directions, one shades up, one shades down, they never cross. The shaded areas never cross. So this system has no solution. It does not mean that every parallel system will have no solution. After all, if I shaded the black line down and the blue line up, I would have the overlapping area be the little zone between them. It all depends on the symbols. You have to graph very carefully. I think drawing the little guy on the line helps guide your shading. I think it's a good idea. All right. So my suggestion, attached to the link for the video, I'm also providing 2 links for Khan Academy videos, just if you need more information. You might not. Also 1 link for Khan Academy practice, if you feel like doing some extra practice. That's not the homework. That's just extra work if you need some practice. The work is going to be a attached worksheet for graphing linear inequality systems. All right? I need it to be completed. I need you to take a picture and send it back to me. It's a riddle worksheet. And if you could do that, please, by the end of the day, or no later than, tomorrow morning. Otherwise, that's all I got today. Have a great day.